So I thought I'd take you through this little single cylinder 4-stroke engine. I've made a lot of it, I haven't finished it yet, but I thought I'd take, a lot of people are showing interest in it, so I thought I'd talk you through it. So it's 4.3cc, it's got a bore of 17mm and a stroke of 19mm. The intention is that I only operate the exhaust valve. The inlet valve will open as we go into the piston drops and we get the suction stroke, the inlet stroke. It will pull the inlet exhaust open with the depression, and then when it gets to the bottom the inlet valve will close with a spring. We'll go and compress the gas. The gas and fuel mixture will be ignited with a spark plug, this tiny little spark plug here, and that will then give us a power stroke. Then once at the bottom of the power stroke, the exhaust valve will actually be actuated, open, and the engine will continue to rotate, and the exhaust will be pushed out by the piston going up. Now if I just take it apart, and show you sort of gradually, we'll deconstruct it and show you where I've got to. But first of all, I've got a mild steel head that actually protrudes down into the liner slightly. You can see that little step there, there's a slight step. I've got a steel piston, steel liner, aluminium main barrel here, and then I've got an aluminium crankcase with aluminium brackets bolted and welded onto the crankcase itself. Now that was quite a problem, and if you look at my blog you'll see all the issues I've had with that. And then you can just see the conrod's aluminium, connecting rod's aluminium with a little phosphor bronze bush just in the bottom there. And the crank itself, you can see, has an offset weight. So if we take the flywheel off, we'll gradually deconstruct the engine. So we'll just take the flywheel off. I'll have to just hold this against me to undo this. There we are. So let's just undo that. Undo that nut. There isn't much of a mounting here for this on the shaft for the flywheel, but now you can see there's a sealed ball race in the front here, and you can see the actual crank just sticking out that. That's it. So let's just take off these. You always get the Allen key that's just slightly worn. There you are, it's better. Just release these bolts, these cap heads. You can just hear them, they're done quite tight, these. That's all made by me. So let's take off these, remove these. There's 5 bolts in here on the crankcase here. It's quite difficult to actually get to the top because I've got a cover here over the camshaft. Now you'll see the cam is done on it's behind this cover, so that's how I get my 2:1 ratio for driving the exhaust valve. Bolt out the last one out here, and then so that's that, and this has come off. Now on the crank itself, you can see that I've machined a gear in here. Now there's a mod 0.7 gear tooth in there, and then you can just see peeking through there the teeth of the cam itself, so it drives it at 2:1. If I just undo this bolt here, find the right Allen key. We'll get the right one. Yep. So the Allen key, this Allen cap head bolt here actually forms the shaft for the gear as well. So it's I've modified a steel cap head bolt. It's got a bit of thread on it, and then it's machined down. And what happens is, if I just then finds out this, So the actual valve cover slides in there with the gear in it. So this is the gear for the actual valve. There's no cam ground in here yet, so there'll be a cam profile for the exhaust ground onto here, and then this will be hardened. There's a phosphor bronze bush in the centre that might have to come back out so that I can actually harden this. But you can see then I've got a 2:1 gear ratio for that cam drive. So when this sits on the front here, let's just show it operation. Let's take off the cover, put this back in, and this will be, if I just put the shaft back in, we can actually watch it. So put the shaft back in, put the shaft back on the front here. The head of that bolt locates in the case here. There you are. So now when the crankshaft rotates, rotates, we can see it's quite stiff actually. So as it rotates, we can see this camshaft rotating. So that's the cam gear rotates with the engine at half the speed of the engine. Okay, so that's the cam. If we then looked inside here, what we can do is pull this apart and we can actually see the piston. So let's do that. Find the right spanner. A little while since this engine has been apart, so it's actually a little while since I've worked on it, so it's looking rather good. I mean, it'll come back at times. I just get carried away and work on another project, and then all of a sudden this will become very important to me, and I will end up finishing it off. I suppose something just annoyed me while I was making it. Something I just couldn't quite solve at the time, and that was around the valves, and we'll look at the valves in a minute. And I just got annoyed with it. Now, so the cylinder and the liner have come off, and you can see the liner in there. That's a steel liner, and now you can see the piston itself and the gudgeon pin. So if we just take that off, so the piston and com rod come off, like that. There's the little piston and com rod. It's rather nice, isn't it? It's very small. You can just see the pure scale of this engine now, how small everything is. And now we can take the crankshaft out. So I've got a bearing on there that's on there quite tight. I'm going to leave that on there. But you can see now the actual crankshaft. You see the running surface for the front bearing is there. Here's the teeth, as I said, for the timing to drive the camshaft. Here's the main bearing on the back, and then here's the weighted, offset weighted crankshaft with the big end. So that fits in the crankcase itself. In the crankcase, you can just see the machined-in space for the com rod to move. This is an engine that's long stroke, and needs quite a lot of space for the crankshaft, for the com rod to move and get the clearance. And then if we just look here, this is the valve that I talked about that I started machining. So here's one of the valves. This valve then fits in place, and you can see what it needs is a bit more work on machining the surface of the seat for the valve in the head, and the alignment of the phosphor bronze running guide, valve guide. Those weren't machined together, and so I've got a problem. What I've got to do is machine the whole valve seat and put the guide in and get that all machined in one go together. So I'm just going to have to machine those back out, or just take them out and then just put new guides in, undersize with the whole undersize, line it all up, machine this valve seat and machine the guide hole itself, and then that will then allow me to get a perfect seat on those valves machined. This valve itself is made from stainless steel. It's a fairly typical material for model valves. They're not going to get overly hot. It's going to run for a fairly short time, this little engine, but it works very well.